What is calculus? Calculus is the study of how things change. So the mathematics that you've been doing up to this point has been what we call pre-calculus mathematics, which is more static, while calculus is more dynamic. So for example, finding the slope of a line, you've been able to do that with pre-calculus mathematics because the slope of a line doesn't change depending on where you are on the line, right? At any point on this line, the slope is the same. But if you're dealing with curves, their slopes change as you go along the curve, right? Which means you need calculus to be able to analyze the slope of a curve. We're going to be dealing with three main topics in calculus. The first one, limits and continuity, followed by differentiation, followed by integration, right? We're going to start, as I said, with limits and continuity. The first topic in your syllabus, module 3, is actually limits and continuity. But we're going to start with limits, and then we'll get into continuity, and then you'll see the relationship between both, right? So, limits. The concept of limit is actually very, very important for the formal development of calculus. I'm going to see if I can give you a gentle introduction to the whole concept of limits. I want you to consider a circle. And within this circle, we're going to inscribe a polygon of n sides. So let's say we start our polygon with 3 sides, which of course is a triangle. It's clear that the area of this polygon, right, of this triangle, is less than the area of the circle, because of course the triangle is within the circle. Now, what if I increase the number of sides of my polygon? So instead of 3 sides, let's make it 4 sides. Then the area of my polygon has increased, but it is still less than the area of the circle. Let's say I increase again, and then I increase again, and then I increase again. And the more I increase the number of sides of my polygon, the greater the value of the area. Until the area of my polygon is very, very close to the area of my circle, but it is still less than the area of the circle. So how we'd write this now, when we're dealing with limits, is that the area of the polygon goes towards, right, or approaches, or gets closer and closer to, that's what this symbol here means, the area of the circle as the n approaches infinity, or in other words, as n gets larger and larger and larger, right? So the area of the polygon approaches the area of the circle as n goes towards infinity, or as n gets bigger and bigger and bigger. The actual way that we'd write it using our limits notation is lim, right, area of the polygon, and then below the lim, n goes towards infinity, is equal to the area of the circle. And these are saying the same thing, but this is the notation that I will use most of the time. The limit of the area of the polygon as n increases, or as n goes to infinity, is equal to the area of the circle. Again, in other words, the area of the polygon approaches the area of the circle as n increases without bound, right? N goes towards infinity. And that's the concept of limit. Limits has many practical real life applications, but we're gonna actually start working limits using numbers so that I can give you a more concrete idea of what limits is actually all about. We're gonna start off by finding the limit of a function. The function we're going to find the limit of is root x minus 1 over x minus 1 as x goes to 1. Right, so this is saying find the limit of this function, which is root x minus 1 all over x minus 1, as x approaches 1. That's the notation. And I'm going to use my calculator and a table to keep the values as I work them out. Now, it's important to note that as x goes to 1 means that we're approaching 1 from both the left side and the right side. So if you consider your number table, there's the number 1. We want to plug in values into this function from the left of 1 as well as from the right of 1. So we're looking at values like 0, 0.5, 0.9, 0.999, and so on. Or from the right of 1 would be values like we start here, 1.5, 1.1, 1.001, 1.0001, and so on. So those are the values we're going to plug in and see what kind of function values we end up with. So let's say x and my f of x. I'm going to start by plugging in values from the left. So I'm going to plug in, let's start with 0.5. So we're going to take 0.5, and wherever there's an x in this function, we're going to plug 0.5. So square root of 0.5, take away 1, divided by 0.5, take away 1. And we end up with 0.586. And let's get even closer to 1. Let's plug in 0.9. Right, wherever there's an x, we're going to place 0.9. We end up with 0.513. Let's get even closer. Let's try 0.99. This time I get 0.501. Let's do 2 more from this side. Let's do 0.999. I get 0.500. I'm doing 3 SF. And then let's save 1 more. And this time I get the same 0.5 0, 0. So it would seem as if as x approaches 1 from the left, right? So we're coming from the left, values that are to the left of 1 but close to 1. I started relatively far from 1, 0.5, and then I got closer, 0.9, 0.99, 0.999, and so on. And you would note that our function values seem to be approaching 0.5. Now we need to do it from the other side as well. We need to approach 1 from the right side. This time I'm going to start with 1.5, right? So again, wherever there's an x, we're going to plug in 1.5. I get 0.449. Let's get closer to 1. Let's say 1.1. This time I get 0.488. Let's try 1.01. .499. Two more. Let's add another 0 in there. 1.001. If I do 3SF, I get 0.500. One more. Let's add in another 0 right there. And I get the same 0.500. So I would make an educated guess, right? And estimate that the limit of this function as x approaches 1 is actually 0.5, because from the left as well as from the right, as we got closer and closer and closer to 1, our values approached 0.500, right? From the left, these are the values we got. From the right, these. So that would be an educated guess, an estimate actually. Now, this is not the way I expect that you're going to work your questions. When I give you a question to find the limit of the function, you're not going to actually be plugging in values like here and making educated guesses, right? There are rules and so on that we will follow to be able to work out the limit of a function such as this one. Now, something I want to point out that's very, very, very important. Limits is about approaching a particular value. You will notice that I did not plug 1 into my function, right? At no point did I use a value of 1 for my x, because for limits we're only concerned with what value we're going towards. We don't want to actually use that value. We don't care about the fact that it may or may not work, because for example in this one, if I should take 1 and substitute into this function, I would actually get something that's undefined. But for limits, we're not concerned about what happens at the value. So we're not concerned about what is happening at x equal 1. We just want to know what is happening to the function as we go towards 1, both from the left and from the right.